Hi, welcome to everyone just joining us. We are going to wait 1 or 2 more minutes so people have a chance to connect their audio before diving into our presentation today. But I just want to start off by saying welcome, and we'll get started in just one moment. Okay. Hi, everyone. Welcome to the second webinar for NASA's Watts on the Moon Challenge. We are thrilled and excited to be here with you today to dive into the webinar and to meet some fantastic panelists that we have on our team. I am going to pass it over to Denise, who will talk through our agenda.
Hello, everyone. My name is Denise Morris. I work for Centennial Challenges at NASA Marshall Space Flight Center in Huntsville, Alabama. And we have a packed agenda today. We're going to do some welcome introductions and housekeeping. We'll talk a little bit about Centennial Challenges. I'll do a quick Watts on the Moon challenge overview. Then we have our panelists. We have the HeroX presentation, an inaugural presentation, Sandia National Lab presentation, and then we'll go over the challenge website, followed by some registration and eligibility rules, and then we'll have some open Q&A. So welcome, everyone. So for the introduction, Manzi Rahman is our program manager. She works for NASA Centennial Challenges, and I am her deputy and also the challenge manager for Watts on the Moon. We have Miss Elisa Ferguson. She is a challenge manager. She is a consultant that supports us and helps us with our technical requirements we have for the challenge. We have John Scott. He is the STMD principal technologist, and he works at NASA Johnson Space Center in Houston. And then Kyla Jeffrey is the VP of Customer Success from HeroX, and they're an administrator of our challenge. So for challenge administrators, NASA Centennial Challenge owns this challenge. We lead the development and execution of the competition to ensure that the outcome meets the overall needs and goals of NASA. We also provide the prize funds for the prize purchase for this challenge. We have Glenn Research Center in Ohio, and they're actually our lead center. They're the technical lead and subject matter expert, primary for helping us define our challenge goals, the success criteria, and the technology with the infusion paths to make sure that we hit the marks for what NASA actually needs. And then we have HeroX. As I said, Kyla is the VP of Customer Success that helps us with the challenge role. She helps us with these webinars. We use the HeroX platform. She manages our competitor interface, including the challenge website, and she confirms the eligibility requirements for the competitors. So I'm going to hand this over to Dr. Kurt Sackstetter from Glenn Research Center. He'll tell you a little bit about Glenn and how they're the lead center for this challenge.
Thank you, Denise, and hello, everyone. I'm very excited about being a participant in this challenge. I wanted to say just a few words to introduce the role of the Glenn Research Center in the agency. Glenn, which is in Cleveland, Ohio, leads the agency's technology development and engineering of NASA's power systems. And these power systems support the development of a variety of exploration vehicles and spacecraft, lunar and planetary surface exploration, so that would be various assets that NASA would place on lunar and planetary surfaces, ranging from habitats and resource processing plants, mobile vehicles, etc. And then on the aeronautics side of NASA, the Glenn Research Center is also responsible for the technology development and engineering of electrical systems for electrified aircraft propulsion. So there's quite a wide variety of both space and aeronautics applications of these power systems. So included in the technology development and the flight system engineering are power generation systems that range from radioisotope type devices, photovoltaics, etc. Energy storage systems, many of which are electrochemicals such as batteries or fuel cells, but it also involves other mechanical energy storage things and thermal energy storage devices and systems. There are power systems engineering, which is meant to be how all of these power generation and energy storage devices sort of all interconnect and work together. And then in addition to that, there are power distribution and conversion devices that range from cabling and other things and power conversion devices between, say, different voltages, conversion between thermal and electrical, heat dissipation, things like radiators, etc. And then finally, power systems involve a great deal of testing to gauge performance of systems, their durability under a variety of conditions, but specifically in the various harsh environmental conditions of space. So next slide, please. So I'm not going to talk through this slide, but I prepared this as a resource for kind of offline viewing by the participants in the meeting to kind of give you a little bit more detail about the things that happen at the Glenn Research Center and why it is relevant to this challenge. At the bottom of this is something that I didn't talk about very much, and I will not, but it does give an overview of some of the space power development and testing facilities that would also be relevant to this challenge. So with that, I will stop, and thank you, Denise. I look forward very much to learning what the external community has to offer in power systems for the moon. Thank you.
Thank you so much, Kurt. Before we continue further into the webinar, just some administrative items. As Denise mentioned, we will be taking questions at the end of this webinar presentation. If you have questions, you'll see a Q&A box at the bottom of your screen. Please go ahead and submit your questions in there. You can do that at any time, but we will be holding off answering your questions until the end of the meeting. If we're unable to get to them, we will do our best to get to them following this webinar. And you don't need to worry about scrambling to take notes or anything like that. We will share the recording, and that will be on the HeroX.com website. So HeroX.com/WhattsOnTheMoon.
Okay, so I'd like to introduce again Ms. Mazi Rahman. She will be talking a little bit about our Centennial Challenge program. Next chart.
Good afternoon, everybody. Thank you so much for the opportunity to tell you a little bit about what Centennial Challenge is. Can you hear me, Denise?
Yes, we can.
Okay, perfect. Centennial Challenge is part of the, it provides NASA prize purses for technology development and demonstrations from the public. So we were established as a prize to conduct prize competitions in support of the Vision to Space Exploration and ongoing NASA program. So we are aligned with a NASA need. Every competition is aligned with a NASA need. So the demonstrations are part of what we use to help us understand what things might be out there that we might have not considered in the past. The use of prizes have been used for a very long time. You might want to go and if you're not familiar with the Ortiz Prize or the Ansari X Prize, you might want to go and look into those and find out, the advantages of using prizes to look for potential solutions that we might, brand new, innovative solutions. And we were created under the NASA Prize Authority that you can also research. There's a link in there, and to understand why we have some constraints related to legal and such. So next chart, please. We are part of an ecosystem of NASA competitions, crowdsourcing, and that NASA has available for the public. NASA Centennial Challenge, it's the one that normally offers the biggest prize purse, and it is they are direct NASA competitions, but there's other also that you might want to look going to the NASA Solve website, so you can get more information about that there. Next chart, please. We have currently actually 7 challenges open. Deep Space Food open and Break the Ice is open. So we are extremely busy. You can go to our website and look for that information. But also, I would like to ask you to look for the 3D printed habitat challenge that closed last year. The results of that competition have been amazing. So if you want to understand and see what possibilities and what things could happen after the completion of a competition, looking for information about that NASA competition would be really very good. Next chart, please. And passing this back to Denise.
Okay, so I'll do a quick challenge overview. We went into a lot more detail on our first webinar, so you can go to the HeroX website and find a lot more details. But for the quick overview, the goal of the Watts on the Moon Challenge is to offer a prize purse of $5 million. For phase 1, it'll be $500,000, and then we'll do $4.5 million in phase 2. Currently, we're in phase 1. For phase 1, we'll present one mission scenario with 3 mission activities, and you can choose to do all of the mission activities, 1, 2, or 3, and you'll get a prize purse for each individual one. Right now, we are on our second webinar, and this competition will close March 25th of this year. Next chart. So as I said, phase 1 is $500,000, and it's about 8 months. Phase 2 is $4.5 million and about 28 months. So we'll have 3 first place prize purses, and they will be $100,000 each for each mission activity. So you could get $100,000, $200,000, or $300,000. And then we'll have up to 4 additional prize purses for $50,000 each. So we'll have $200,000 in the $50,000 prize purses. Next chart. So now I'm going to introduce to you our first panelist. We have Colonel Charles Brisbois. He works for the HeroX team, and that is the Air Force's innovation arm that just launched the Reimagining Energy Challenge. You'll see a lot of similarities between their challenge and our challenge. So welcome, Colonel Brisbois.
Thank you, Denise, and thank you, Monsi, and the whole NASA team for putting this together and inviting the Air Force to join in and give you a little understanding of our challenge and what we're working on. So as a little bit of background, this first slide says, 2 big acronyms, HeroX, and then my organization, which was formerly AFWIC, the Air Force Warfighter Integration. It's now Air Force Futures. If you're familiar with Army Futures, all of the services right now, whether it's the Marines, the Navy, Army, or the Air Force, are taking deep internal looks at themselves and saying, how do we change to remain relevant on the battlefield, right? And because of the dispersion of technology, because the introduction of AI and microelectronics that allow others to do sensing, space-based satellites, there's all of our competitors are eating into this huge advantage that we've had, and if we don't do something to change, we're going to lose our competitive advantage, right? Because we've been the Goliath on the global stage of militaries, but our enemies and our competitors have found our Achilles heels, and they're using technologies to eat into those. And so part of what our new chief, General Brown, the Air Force Chief of Staff, has come in and said, he put out a paper and said, we have to accelerate change or lose. And many of you in the audience have heard me talk about this already. But he and his predecessor, General Goldfein, the former chief, both looked at the situation in the Air Force and said, we've got to change the Air Force at a pace and a scale that we've never done before, and how do we do it? And so 2 of the solutions were 1, let's build an organization that looks at the future of the Air Force in 2030 and beyond, and ties that that view of the Air Force and our theory of victory and how we're going to remain competitive to capability development. And then let's have somebody that stretches that a little bit and looks at the real far out things, you know, all the things that OSD-R&E, Office of Secretary of Defense for Research and Development, has said it's important. How do we bring AI in? How do we bring quantum in? How do we bring microelectronics manufacturing back to the United States and get those into our weapon systems, get the latest technology into our weapon systems faster? And so our organization and my division, Disruptive Technology in particular, is kind of charged with doing that, right? And scouting and scanning the environment and then bringing companies and capabilities into the Air Force faster. And we're just part of a larger ecosystem. Another part of that ecosystem is the AFWorks, and they were created to be the front door of the Air Force, right? If I've got the requirements and I understand our theory of victory, they've got the connections to industry and they've got the tools and the contracting and some of the funding to run these challenges. And so it was a nice marriage. We came together. They said, give us a big strategic problem that's important to the Air Force. And the first thing that came to our mind was energy. And in the future, right, the big challenge is that our competitors know that we need large amounts of energy and sources of energy to generate combat power. And if you take that away from us, if you blow up our fuel dumps, or if you interdict our pipelines and our supply lines of POL fuels, suddenly you can stop us from generating combat power, right? And do it in a very efficient way. So we've got to rethink our logistics, and we've got to rethink our energy, especially since we're the DoD's largest user of energy. So we created this challenge. And next slide. And this is basically a timeline of where we've been. We're in, obviously you see we're finalizing it, and we're going to our showcase. And I'm sure, you know, many of you that are on this line and are applying or interested in the NASA one heard about it and applied to ours. And some of you have been invited to our showcase. I will say that we're going to follow this up. At some point, there's going to be an energy prime. We're doing the exploration on that right now and looking, but we will, you know, some of these challenges are graduating into bigger projects, which the Air Force is calling primes now, if you're familiar or heard of those. Next slide. And so what did we go after in our challenge? And this is really, you know, where Monty and Denise think that we have a lot of overlap, and we absolutely do. And you know, and it's great that the governments come together and we have the Air Force and NASA, you know, informing each other and working together on these things. But our first category was generating energy, right? So what are the new ways, which ways, how is technology allowing us to produce energy in new and novel ways? And then distribution, right? You produce it, but then how do you get it out to the actual users? And storage being the third. So the three big were how do you generate, transmit, and store energy? And then we added, through multiple workshops, we added, you know, the idea that we need to look at operational equipment. What new ideas do electrifying equipment bring out, and how could you use that, and what's the military utility of it? And then data and mission planning, and you know, using data to be more efficient. What can we do with all the data that's being generated, and how does that help us? And then finally, culture, policy, and education. You know, what parts of all of those need to change in order to do this? And so, you know, as you saw on the previous timeline, we started this about 6 months ago. We've been through the down selects. We have invited companies to our showcase, and that's going to happen next month in February. Next slide. And then, so this breaks down kind of those categories again that I just talked about a little more. You can see inside of the data, you know, 4 lines of what we're looking at. Culture, policy, and education, again, specifics of companies that we invited, the transmission and distribution. You can read through them, but that's just a little more in-depth detail of kind of the things that we're looking at and exploring. And really the idea is just like our challenge says, is how do we reimagine energy, and how do we do it in such a way that, you know, allows the Air Force to move away from our traditional lines of energy and ensure that we have the proper means to generate, transmit, and store that's going to allow us to generate combat power in the future. Next slide. Yeah, I think these were actually supposed to be hidden. So jump over the next one. Yeah, and then it was question and answers. So I think that's all I got, Denise. I'll turn it over to the next group.
Okay, thank you. That was a great presentation, and thank you for bringing us up to speed on what you're doing. So next up, we have Kumar Prabakar. He's from NREL. It's the National Renewable Energy Laboratory, and he works as a research engineer there. So he'll be discussing the AC microgrid controllers with us. Welcome, Kumar.
Hey, Denise, thank you. Hope everyone can hear me. I'm Kumaraguru Prabakar. I'm a senior research engineer at the Power Systems Engineering Center at the National Renewable Energy Laboratory. Next slide, please. So I work in Energy Systems Integration Facility at the National Renewable Energy Lab. It is what we call a user facility located in Golden, Colorado. So we primarily work on renewable energy integration, and I specifically work on systems integration side. And our facility is very unique, where anyone in the world can come to us, to solve a renewable energy problem, and we'll try to help them solve some of their renewable energy integration issues. Next slide, please. So I primarily work on controller and power hardware in the loop experiments at National Renewable Energy Lab. We have megawatt scale power hardware in the loop capabilities that allows researchers and manufacturers and utilities to test and evaluate energy technologies at megawatt scale before integrating into the field, and this helps in de-risking some of their investments before they go into the field. And we primarily, also work on a lot of utility studies, co-simulation between different power system simulation platform. And today I'm going to talk about one of our microgrid controller evaluation projects. Next slide, please. So the project that I'm going to talk about today is designated as a high impact project because we were going to evaluate a microgrid controller for a utility from California, and it's a large team led by San Diego Gas and Electric. We have University of California, San Diego, and a couple of vendors that provided the platforms for this microgrid. And NREL's role in this project was to evaluate the microgrid controller functionality before it can be integrated into the field. Next slide, please. So the primary team is this from NREL. We have a couple of folks, and we also have San Diego Gas and Electric and Spirit Wave, which is the microgrid controller provider, and University of California, San Diego. Next slide, please. So the microgrid controller that we were evaluating was supposed to be installed in a small community called Borrego Springs that is a little west of San Diego. And this is an ideal community for a microgrid because this community was primarily fed by a 69 kV transmission line that goes over forests, which has a lot of wildfire possibilities, and adding another transmission line would be very challenging and very expensive. So this is an ideal candidate for a microgrid, and this particular community also has a lot of customer-owned solar generation, and it has a mix of loads all the way from agricultural loads, which has pumps, to normal household loads, lighting loads, air conditioner, and heating. Next slide, please. So this is a model that we used for evaluating the microgrid controller. As you can see, that the main loads are being supplied by a 69 kV substation, and we have a large PV plant that is at the 69 kV bus, which is almost 26 megawatts. The peak load for this microgrid was anywhere between 10 to 20 megawatts. So this is this has more than 100% of renewable energy penetration. This microgrid also has a couple of diesel generators, which act as the voltage and frequency master, and it also has a couple of battery energy storage systems. And that feeds the microgrid circuit, and it has multiple point of common coupling that can island the microgrid from the main grid if there was to be an issue on the grid side, and then it can resync back to the main grid once the grid comes back. Next slide, please. So in microgrid controller evaluation, there are multiple ways that people typically use. The first one is pure simulation, where everything is modeled in a simulation platform like an EMTP, MATLAB Simulink. There are a lot of ways to do this. And then the next one is a controller hardware in the loop, where the model, the microgrid model or the power system model is run in a digital real-time simulator, and we interface a microgrid controller through the normal communication protocols that it will use. And the third one is a hybrid experimental setup where you use both controller hardware in the loop and power hardware in the loop. And that's sort of the niche of our energy systems integration facility, where we can leverage our megawatt scale experimental facility. We can bring in the same inverters and other power devices that are going to be installed in the field and evaluate both the power hardware piece and also the controller hardware piece in the system. And the last one is a hardware only approach. It is very rare that people use this because we would have to emulate the whole microgrid, which becomes extremely expensive. So for this project, we used controller hardware in the loop and power hardware in the loop setup to evaluate the microgrid controller functions. Next slide, please. So the controller hardware in the loop and power hardware in the loop setup here uses a couple of power hardware setup. One is modeling the PV inverters that are in the field, and the other one the battery energy storage system. And on the controller hardware in the loop side, we have modeled the diesel generator controllers in controller hardware in the loop, and also the main controller, which is the microgrid controller that will sense everything that's happening in the microgrid and send control commands to operate the microgrid both in economically and also in a resilient fashion. Next slide, please. So this shows some of the hardware setup that we have in the lab. We brought in the same microgrid controller that will be installed in the field. We have the same diesel generator controllers that exist in the field, and we used RTDSs that model the power system in EMT domain in real time. And we have close to a megawatt of power hardware, both on the AC side, which we use AC grid simulators, and on the DC side, we use 500 kVA PV emulators and another 500 kVA battery energy storage emulators. And then we interface this power hardware to our digital real-time simulators. And also the controller hardware is interfaced to the digital real-time simulation using communication protocol like DNP3 and other digital communications. Next slide, please. So I presented a couple of cases in this presentation. So first one is a plant disconnection, where the utility knows that they want to island the system, so which is a planned event. And we ask the microgrid to orchestrate the event, where we say, okay, let's go into an island mode, and then the microgrid controller will start deciding which asset will be the voltage and frequency master, and then start deciding which assets will support the P and Q demands of the load. The plots here show that the event was smoothly transitioned. So before we send the command, you can see that the currents in the third plot on the right, there is current flowing in the PCC circuit breaker, but once the microgrid was islanded, the current went to zero, and the microgrid controller was able to maintain the voltage and frequency once it goes into that mode. Next slide, please. So this one is an unplanned disconnection. We had a lot of unplanned disconnection events modeled, but in this plot, I'm just showing one event where we simulated sort of a voltage or a frequency event on the grid side, and the microgrid controller tried to maintain the voltage and frequency inside the microgrid. The main isolation or the islanding mode happens using the protection equipment, but the microgrid controller decides on the high level and orchestrates all these devices and makes sure that the voltage and frequency are within the bounds of the utility. Next slide, please. So the summary, we built this hardware in the loop setup that is very useful in evaluating microgrid controller functions, inverter functions, energy storage functions before it can be installed in the field. So this helps in de-risking the investments before they go into the field. We identify a lot of bugs that could have caused some issues in the field, but where we can capture it and then give some feedback, and those can be updated before going into the field. On the RTDS and the digital real-time simulator side, we use models that are very close to reality. So this is probably the closest where you can evaluate some of these things before it can be installed in the field. We ran a lot of cases. I presented only a subset of the cases that we ran. In the next slide, I have a lot of references where we published most of our results, and California Energy Commission, which funded this project, also have a report on all of the use cases and more information on the microgrid and the microgrid controller functions and things like that. With that, I think I conclude my presentation. Thank you.
Thank you, Kumar. So the next panelist we have up is Dr. Jack Flicker. He worked for Sandia National Labs as on their technical staff. He will discuss DC microgrid development for long-term lunar habitations. So welcome, Dr. Flicker.
Hi, thank you. Hi, everyone. My name is Jack Flicker from Sandia National Labs, and I'm going to be giving a brief overview on a 2-year project that we just started a month or 2 ago to study robust, autonomous, fault-tolerant DC microgrids, especially for long-term lunar habitation. So you can go to the next slide. So most of my work as part of Sandia's Renewable and Distributed Systems Integration Group involved terrestrial-based microgrids and islanded grids, especially in very challenging environments. So this especially includes islands and remote villages. So you may be asking yourself, why the heck is Sandia, a Department of Energy laboratory, doing any sort of this work in space-based microgrids? So you can go ahead to the next slide. And the answer is that there was recently signed a memorandum of understanding between DOE's Office of Electricity, which recognizes the crossover potential of space-based and terrestrial microgrids. So they signed this memorandum of understanding between NASA and DOE so that research and researchers in one of those areas can inform and impact the other. So some of the work at Sandia that we do on very high resilience microgrids we think has direct applicability to the space-based applications, and then vice versa. So go ahead to the next slide. So Sandia is working on a project funded by the DOE Office of Electricity to work in collaboration with our partners at NASA to bring some of our tool sets and capabilities in the realm of terrestrial microgrids and apply to this application of long-term space-based microgrids. So the overarching target for NASA is crewed lunar operations sometime in about the 2024 timeframe. This project, which is known as Artemis, is key for overall NASA aims because it can use the moon both as a technological staging ground to prove technologies for an eventual Mars mission, as well as a literal staging ground for a future Mars mission. And the primary piece that we're concerned with at Sandia is the electrical infrastructure that's necessary for this long-term habitation. As you can imagine, any electrical infrastructure or long-term habitation in space has some pretty key design criteria, and this includes things like modularity in order to reduce sparing and thus payload weight, has to operate autonomously, and it has to be able to have fault robustness so it can operate and mitigate faults as they happen. So go ahead to the next slide. Of course, there's been a functional habitation electrical grid out in space for over 30 years now in the form of ISS, the International Space Station. However, a moon-based type electrical grid has some very key differences, including a significantly larger geographic distribution. And this means that you can incur stability issues as generation interacts over these longer distances. And there are also some significant differences in both the loads and the assets that are expected to be on a moon base, as opposed to what you'd see in something like an ISS. So on the asset side, there's some generation sources that can be used, such as RTGs and fission generators, that you're not going to find in this constrained ISS type environment. For safety reasons, some of these assets will have to be significant distances from the habitation area. Then on the load side, they're expected to be quite a bit of mining and fuel production type activities on the moon. And again, this is somewhat removed from the habitation areas because you don't want to put all that industrial type loads right next to the habitation area. So all this leads to a very significant heterogeneity in both the loads and assets that's distributed across a relatively large microgrid. So these issues where you have large area power distribution, heterogeneity in the assets and the loads, and significant distributed generation tend to be very similar to the issues that we face in a lot of the terrestrial microgrids that we look at. So you can go to the next slide. So one of the primary activities that we're looking at is studying basic system design. So that involves understanding the trade-offs for asset mixes and sizing of the system. So sizing it appropriate for all usage scenarios, both in the present as well as expected usage in the future. And also takes into account evaluating different system topologies that can increase resiliency. So we're also looking at developing and evaluating autonomous, robust control schemes that are stable to communications failures or latency. And the main focus behind this is the ability to operate in both kind of normal operating modes as well as contingency events. What we in the terrestrial microgrid world called a quote unquote blue sky or a black sky conditions. Although I recognize that that has quite a bit different meaning in this context. But what we're really concerned with is control of all of these distributed units and balancing collaborative control or making sure the system is at an optimal state overall versus competitive control where each node tries to ensure that it has enough power to meet its own local load requirements, and that may come at the expense of sharing energy between nodes. And this may be a dynamic type situation where under blue sky type conditions, we're looking to ensure system optimality, while in black sky or contingency scenarios, we're concerned not necessarily with system optimality, but more with system stability and making sure that we can keep the lights on, even though the mode is not in the most optimal system state. And finally, we're also looking to evaluate fault detection, mitigation, and ride through of these robust DC microgrids. So you can go to the next slide. So as a very broad overview, we're utilizing some of our tools and expertise that we've previously utilized for terrestrial-based microgrids, both AC and DC, and applying them to space-based environments. And we're leveraging the work that we've done with microgrids with significant distributed generation, large heterogeneity in load and sources, and in very harsh or remote environments. And we're focusing on system performance and resilience benefits that are enabled specifically by power electronic-based hierarchical microgrids. So you can go to the next slide. So what do I mean by hierarchical microgrid? A typical high resilience microgrid is what you'd see on the left here, where you have a central bus with generation and sort of unidirectional power flow to different nodes that all contain loads. This is compared to a hierarchical microgrid, which you see on the right in a schematic. And this microgrid has generation, load, and storage at each node with power electronics interconnecting each node. So what this does, it allows for a sort of hierarchical topology so that the microgrid is designed in sort of these three distinct layers, each of which can operate independently and operate within each layer or coordinate as needed between the layers. So really at the base layer, you have what we have as a node, a house, or another load, which we call a nanogrid. And these nanogrids can operate totally independently from each other if needed. At the second layer, you have a connection of nanogrids inside of a microgrid, which is connected and tied together by a common bus. And at this third layer, you have this interconnection of microgrids and to make a grid of microgrids. And the key to this is that since each node can operate independently, it allows for greater autonomy and flexibility than would be possible with a traditional microgrid. So you can go to the next slide. So we're working on evaluating system models with appropriate assets and loads, developing autonomous control schemes that are robust to communication failures and latency, and then working on some hardware where we utilize hardware in the loop experimentation as well as some of our hardware assets to evaluate the performance of these hierarchical power electronics-based microgrids. Go ahead to the next slide. So one of the systems we'll be using to evaluate these hierarchical DC microgrids is a microgrid that we have operating here on Kirtland Air Force Base in partnership with American Technologies. This is an example of a hierarchical DC microgrid with significant distributed generation as well as significant heterogeneity in both the assets and the loads. And we'll be using it to evaluate the performance of the system in different contingency scenarios. For example, we'll be looking at how power electronics at each of these nodes and interconnection levels allows for the flexible routing of power to critical nodes, both in time and space, in a contingency or low energy type environment. I call this the full power to shields test. So you can route energy where it's needed, when it's needed. We're also evaluating the ability of the system to ride through and detect fault conditions. So go ahead to the next slide. We're also using a facility at NASA called a facility at Sandia called the Secure Sustainable Microgrid to evaluate different control schemes to balance system optimality with system stability. This facility is a 3-bus DC microgrid that was specifically designed to evaluate the performance controls in DC systems. And we've used it for a lot of different systems, such as for an electric ship, which you can see an example schematic on the right. So what it allows you to do is to run not only different scenarios with different generation and load profiles, but also to run those scenarios over and over again automatically, adjusting only the control parameters, so you can get a true sense of how the control system parameters affect system performance. So you can go ahead to the next slide. So unfortunately, I think that's all the time I have today, and I just wanted to give you kind of a brief overview of some of the work that we're doing and some of our overarching goals and design criteria that we're looking at to develop these DC microgrids for space-based applications. Thank you.
Great, thank you so much. Okay, so we're going to go into a brief overview of the challenge website now to share with everyone some of the registration and eligibility requirements. I'll actually share my screen directly on the challenge website for Watts on the Moon so that you can understand where all the key information is that you need to know in order to participate. But there are a few items that we want to really highlight, so I have those on these slides as well. The first is registration. So if you would like to participate in the Watts on the Moon challenge, you must submit complete registration documents. And the registration documents are fairly extensive, so we highly encourage you to get started on those early and take a look through those registration documents. As Denise mentioned, it is a 2-phase challenge, and you can participate in the second phase even if you do not participate in this first phase that we're in currently. Of course, we highly recommend you participate in phase 1, but it is not a requirement. Secondly, this is a US only competition. So I know we've had lots of great interest from the international community, and unfortunately this challenge is restricted to US citizens and permanent residents of the United States. You also have to be 18 years of age or older, and there are similar restrictions on organizations that if you are submitting as an organization, it also must be US based, an entity incorporated in and maintaining their primary place of business in the US. And these restrictions apply for everyone participating on your team, whether an individual or an organization. I'm going to briefly stop my screen share, and I will share the HeroX challenge page to walk you through exactly where you can find this information after the call. So this is the challenge page. This registration tab is where you can find the details about how you actually go about registering. There is a competitor documents file that I highly encourage you download, take a look through it, look through the agreements, and understand what's required of you. On your team, you must designate a team leader and create your team on HeroX. And when you register for the challenge, you will be prompted through those steps to create your team. Make sure you're reviewing the team agreement very closely and obtaining all the documentation required. If you scroll down on this registration page, you'll also see a competitor checklist. So again, take a look through this early. There's things like needing to show proof of insurance or certify your financial responsibility as opposed to providing the insurance. So go on, take a look, read through these, and if you have any questions, feel free to send us an email, or another great place you can post them is right here in the challenge forum. If you have questions after our webinar, this is really your go-to place to get a hold of either the HeroX team or the NASA team that HeroX can help get answers from them. Before we move into a Q&A, I just want to play a short video for you that I think is really just exciting and inspiring to get us all ready to move into this challenge.
On Earth, we can light the darkness, power our lives, supply energy for the world's needs. On the Moon, we cannot, or at least not yet. With 350 hours of total darkness and day after day of sub-zero temperatures, traditional Earth-based power storage and distribution technologies aren't going to be enough. Future lunar explorers will need power to use the tools and technologies necessary for uninterrupted exploration and survival on a new world. That's why NASA is searching for solutions beyond our ongoing research. From garage inventors to small businesses, industry and university students, NASA's Watts on the Moon Centennial Challenge is crowdsourcing ideas to solve the difficult tasks of power distribution, storage, and management on the lunar surface, and enhance these technologies here on Earth. As NASA builds a sustainable human presence on the Moon, continuous energy will be a critical piece of this puzzle, so that one day we can light the darkness on the Moon.
Great, so I hope you enjoyed that video. We are really excited about it. We're thrilled for the challenge, and we're going to move into a Q&A session now. So if you have any questions either about the challenge or about any of the presentations that you saw earlier from our partners that are on the call, please put them into the Q&A box at the bottom of your Zoom screen. If you have a question for a specific panelist, please just indicate who that is so we can make sure we're directing it to the right presentation that you're referring to. We will do our best to answer all of your questions. There may be a question that I ask a panelist that they need to go back and give some thought to before preparing an answer, and that is completely fine. And we will follow up with some questions after the webinar as well. Okay, so Denise, I'm going to pass the first question to you because it's about registration that we just spoke about. If someone does not have a team, can they participate as an individual?
Yes, absolutely. You can participate as an individual or a team. It doesn't matter. There can be one of you or 100 of you.
Great, thank you so much, Denise. Okay, Elisa, I'm going to ask the next question for you. And it's about why can we not develop and deploy power generators close to the production plants? Microgrid architecture already exists, and it's evident in some of the slides that were shared that it does exist. Would that not be a feasible and reliable solution?
Sure. So I'm not sure if that question is related to NASA generally or to the challenge. I would just say that NASA is exploring various options for power generation as well as distribution, storage, and management for the Moon. And the project described on the webinar today is one of those. And the mission scenario, the hypothetical scenario that we describe in the challenge rules is another set of options. I'm sure there are others as well. So I can't speak to the credibility of the specific solution that the questioner was asking about, but I think that we're looking at lots of different things. Kurt may have something to add on that from the Glenn perspective.
Yes, as you sort of suggested, Elisa, NASA is already making significant investments in power generation schemes that are adapted for the space environment for deployment on the lunar surface. So that we feel that is very well in hand, but we are looking for additional support for that for the energy distribution, management, and storage. In particular, in these very challenging locations like the permanently shadowed regions. And that is where we hope this challenge will contribute significant additional input into the overall power systems for the Moon.
Great, thank you so much, Kurt and Elisa. Denise, I'm going to direct the next question to you again. This question says, we're very interested in applying to the Watts on the Moon challenge. Is it possible, or what is the best way to get some preliminary feedback from NASA before submitting a full application?
So unfortunately, we can't give preliminary feedback. That would not be fair to the other competitors. So any correspondence from NASA will be posted on the HeroX webpage, and you can see it under the frequently asked questions or question and answers from the webinars.
Great, thank you so much, Denise. There's another question about the webinar recordings. So the Recording from today's webinar will be posted on the HeroX page that I just shared with you. There's an update section, it'll be posted there. There's also a resource section where it will be posted, and you can actually see the prior webinar from November under that resources section as well. So if you'd like to go back, as Denise mentioned, we went a little bit more in depth on the specific challenge in November, and you're welcome to go back and take a look. Elisa, I will ask you the next question, which is, let me just pull this up. What are the current challenges with electronics in harsh environments?
So I would just say in terms of environmental conditions on the moon, there are various harsh environmental conditions, and teams will need to, in the challenge, teams will need to address how their solution is going to operate in the conditions described in the challenge rules, so in that mission scenario. So it's sort of a subset of all the total conditions on the moon, and specifically in that mission scenario, we talk about extreme temperatures, we talk about irregularity of sunlight, and we talk about atmospheric pressure that is essentially a hard vacuum. So those are really the key ones, and it's really up to the teams to determine what impact those conditions are going to have on the solution that they propose.
Great, thank you so much, Elisa. Next up, I'm going to ask a question that I think is relevant to all of our panelists, so please jump in if you have a thought on this. Where does this group see the overlap between energy initiatives on Earth and those that are sought for space?
I don't know, Jack, do you want to go first?
Sure. So the overlap that I see is specifically this idea of hyper-resilience for our electrical energy infrastructure. In terrestrial-based microgrids, a lot of the times they require significant oversight, and we want to move to a portion where, or a regime where we can offer increased resiliency in an autonomous fashion, which directly relates to what is trying to be achieved in the space-based microgrids, but that's to the nth degree, of course. And then in a space-based environments, you have a lot of additional challenges for the type of environment that it's operating in. But I think this backbone of resiliency, autonomy is a tying theme between technologies that can be utilized and frameworks that can be utilized in space-based applications to what we need on terrestrial-based applications as well.
Yeah, I would agree. Definitely microgrid controllers and SCADA systems and a lot of distribution management systems has improved a lot in the last decade. So there is a lot of computational improvements that can be leveraged. I'm not an expert on the environment in the moon, so there's probably going to be some challenges in the environment that's going to interact with the power system. But I agree with Jack's comment. Definitely the microgrids and the distribution systems right now are being developed to operate autonomously and trying to be as resilient as possible, so we can try to leverage those technologies for some of these challenges.
Great, thank you so much. Anyone else on the panel want to chime in before I ask the next question? Okay. Elisa, I will pass the next question to you. Is there a target wattage? Can you talk to us about some of those requirements for the challenge and perhaps where people can find them?
Sure. If that question is about the challenge, if you go to the challenge rules on the website that Kyla showed us, you'll see that there are operational power requirements for each of the mission activities. So and they're all a little bit different because that's on purpose. We're trying to get lots of different ideas for different types of activities and scenarios. So I won't go over all the specifics here, but we did go over some of those in our first webinar, which you can get the recording of on the challenge website. And of course, you can see all of those specifics in the challenge rules.
Great, thank you so much, Lisa. Colonel Brisbois, I'll pass this next question over to you. It's about the HeroX challenge you were talking about. Is that funding available separately for the effort? And can you talk a little bit about kind of what the funding for that challenge looks like, over what time period, and if it's still open for people to participate?
Yeah, so the challenge right now is closed, and the funding. We approached our challenge a little bit differently. We put the challenge out to industry, said how would we reimagine it, and we didn't have a specific dollar amount. Our intent was that my organization, Disruptive Technology, Air Force Disruptive Technology, would work with HeroX to find users within the Air Force that had kind of an operational need for this, and they would be able to use their funding, right? That's one of the hard parts in government, is aligning funding with these. Congress doesn't allow us to just generally have open pots of money, right? So we have to have a requirement and a solution, and then we get funding for it. And so there's some ways around that, but I guess the bottom line to your question is that we didn't have a predetermined amount of funding like NASA has done, and I commend you guys for having that clarity and the ability to do that. What we do have is our AFRL partners, the Air Force Research Labs, are going to come into the showcase along with others, but AFRL in particular is going to fund several of the companies that we pick in the showcase to do some prototyping and demonstrations for us. And ideally, that will lead to further contracts, phase 2 and 3 SBIRs, things along those lines.
Great, thank you.
I'm sorry, to answer your second part, it is too late to enter our challenge. But as I said in the presentation, there will be at some point in the future an energy prime. We're going to select one portion. So we had 6 broad categories of how we reimagine energy. We're going to focus that down, and we're going to pick one really specific area, and I think we're going to make that a prime, and we'll open the competition back up from there to see who's got ideas on that. So.
Great, thank you. There are a few questions about insurance, and I am very excited to see people asking questions about insurance, because it's something that you should start looking at now, as it can take a little bit of time for you to figure that out. So what I will say is everything regarding insurance is posted on the challenge website. Open up the team agreement, find the insurance section, I think it's 6.9, and read that so you have a good understanding of what's required for phase 1. There is an option to either provide insurance coverage or to certify that you have financial responsibility for $5,000. So read through that. That's where you can find all the information. If you have more specific questions, let us know. But I'm glad to see so many people asking about that today, because it is something that I'd encourage you to start looking at and making progress on. Denise, is there anything you want to add about insurance?
No, just to reiterate what you said, it's very important. We work for the government, so they do require that for all of the NASA-led challenges. So as Carla said, it's all laid out clearly in the rules. And if you have additional questions or concerns, you can put it in the Q&A.
Thanks, Denise. And I know there's, I saw at least one question asking about why this is different than NASA's Lunar Delivery Challenge that just closed on HeroX and some of the other initiatives. And so I will just share that, yes, this is different than other NASA projects you may have participated on the HeroX platform. So please make sure you're reading all of those requirements carefully, as they will be new to you if you've participated in other NASA challenges on HeroX. Okay, we are just about at time. That's gone by very quickly, but it's such a pleasure to have everyone join us on our webinar today. It's been fantastic speaking with everyone on the team. If you have additional questions that were not answered today, please do post them in the challenge forum, which I shared with you on the HeroX webpage. And that's really the place to go for questions throughout the duration of the competition. If you've submitted a question today that we didn't get an answer to, we will do our best to find an answer for you and to share it following the competition. There are a few different ways you can stay connected with us. And let me share this slide. And Denise, I will pass this slide over to you. You're on mute if you're talking to us.
Sorry about that. So Yeah, make sure that you complete the required paperwork and submit the supporting documentation. Please make sure you look at all the documentation out on HeroX website. I think that'll answer a whole lot of your questions. You can also follow us on Twitter, on Instagram, and Facebook. And then we have an email for you to submit any questions, or you can post in the challenge forum. That's all I have, Kyla.
Great. And with that, thank you, everyone. Thank you to our panelists from the partner agencies, to NASA. We are so excited. And most importantly, thanks for everyone who attended the webinar. I know the team is thrilled to see what you come up with in this phase 1. And again, please reach out. We want to be able to support you if you have questions that you didn't get a chance to ask today. And with that, have a wonderful rest of your day. Thanks, everyone.